A very good morning to everyone, and welcome to our talk for today. Let me do a quick introduction about myself. I am Elson. I'm the head of faculty for chemistry in TUM Asia, the overseas partner of SIT. So, today we will talk about the joint SIT and TUM Bachelor of Engineering with Honours in Chemical Engineering. Let me first give an introduction to SIT, and later on followed by TUM, before we talk about the program and then conclude for today. SIT is Singapore's first University of Applied Learning, of which I believe most of our students are actually here for. And SIT offers specialized degree programs that helps graduates be ready for work when they graduate. And that is the most important part that SIT takes pride in, right? So SIT partners with a lot of overseas universities, and we are proud to say that TUM is one of them. So for the degree programs, it's separated into different clusters, which you will see at the open house later. Let me talk more about TUM right now. So TUM is actually founded in 1868 by King Louis II. TUM is actually located, the main campus is located in central Munich. And if you've been to central Munich before, there's actually a very iconic clock tower. TUM is the #1 university in Germany, and we are proud of that fact. And in terms of rankings, TUM is actually ranked 30th in the world in the most recent QS World University Rankings. So a major university, and they are very, very strong in a lot of academic subjects. And TUM is actually the #1 in Germany for 5 academic subjects, of which chemistry is also one of it. And chemical engineering, being under the School of Natural Sciences, is closely tied to chemistry. #3 university in Europe, of course, there's ETH and many other major universities. And I think one key statistic that we are also very interested in, TUM is ranked #12 in the Global Employability Survey. What does that mean? That means that every TUM graduate is highly favored in the industry because they are work ready, they are trained to be, and I believe this is also SIT's goal. So we are very in sync in terms of that. What do you get? You get an internationally recognized degree, right? Both SIT and TUM. And TUM being ranked among the best European universities, that means that this will offer our students with a very good global outlook and perspective. TUM is excellent in research and teaching, and especially in recent years, interdisciplinary teaching. So it is no longer a single topic that is in our lives. It is a lot of topics meshed together, and one can't be good at everything at once. We know that. So we require a lot of collaborations, and of which the interdisciplinary thinking would help bridge that gap between different experts. TUM is also very strongly tied to the industry like SIT. And what we are trying to solve is many different applied problems that we face in our real life. Because there's so many things that TUM does well in, including the diesel engine that was invented by a Toronto alumni, which is also one of the Nobel Prize winners. So, of course, there's so many examples to be listed, and this shows that what TUM is committed to doing is to actually help the industry solve real-world problems. TUM has 6 campus locations, and we are proud to say that Singapore is the only overseas campus that TUM has. The other campuses are in Germany. So this venture actually started off back in 2002, where Singapore's Economic Development Board invited TUM over to conduct study programs for our locals to get the more choices apart from our local components, right? So this program is a SIT and TUM collaboration. We cannot stress that more. And it's a very tight collaboration between SIT and TUM till now. And our students actually get access to international expertise, right? Not just from our local professors, local experts. They have the German professors, German experts coming right here to deliver what they deliver in TUM in Singapore. Apart from going through the training of a chemical engineer, our students actually go through Industry 4.0 topics, right? Like in additive manufacturing, in data engineering. Like if you have heard of topics such as Internet of Things, AI, it belongs into, and 3D printing, of course, right? So it belongs to the white umbrella that is Industry 4.0. Okay? So students also go through a flagship SIT program that is the Integrated Work Study Program. It is a one-year program that students have to go through, similar to an internship, but with a study component. And of course, that's just one component of the study that we are talking about. And this one-year program is very unique to Singapore's education system, where may get the chance to get employed in the industry that they interned in or had an integrated work study program in because of their longer study program, that is 1 year. And on top of that, they get the chance to network, they get to learn how to present themselves, and they do a project that is 1 year. So if you are familiar with the science setting, in a lab setting, in a plant setting, it often means that by the time we get past the safety training, it will be a period of typically around 3 to 6 months before we start churning out some useful findings from our research or from any projects we have in mind. And our TUM professors, they actually fly down to Singapore, deliver their course that they deliver in Germany to our students. Currently, the program is located in SIT Dover or SIT at Singapore Poly, but I believe that the major news is that SIT will be moving to Punggol in, I believe, August period. Our program actually focuses on many different things, but fundamentally, what are we doing? We are training chemical engineers with specialized skills. That's what we are interested in, okay? So what forms a chemical engineer? A chemical engineer will have to go through fundamental training in science, and later on, go on to their core modules in chemical engineering, and then they do their specialization in year 1, 2, 3, in that format, okay? So we are trying to equip our students with foundation in chemical engineering, and then provide them with exposure to Industry 4.0 in topics such as additive manufacturing and data engineering, okay? Then, because in the first place, overall, we are trying to solve industry problems, right? That means that our students, they need to have the skill to embark on new ventures. That means that if there's a topic that they will need to embark on in their choice of work, be it, let's say drug manufacturing, right? Then you might need the knowledge in not just chemistry, chemical engineering, you might also need knowledge in biology, right? So our students should be able to, when they graduate, to project such skills. That means that they either have gone through the training, or when they go through a training in other topics, they do not have any trouble in, okay? And then, there is a projected demand in the first place for chemical engineers with skills in the Industry 4.0 topics, which is why this degree program offers it. And it's actually the first degree program in Singapore to do it. I think there are more programs now that expose students to Industry 4.0, but this program is the first. And there is an industry demand. And because of the partnership with TUM, there's actually a very good partnership between SIT and the industry in Singapore, and of course, TUM in Germany. That means that these two institutes, when they join together, there's an even stronger industry linkage. What does that mean for our students? For example, when they may get a chance to actually go to Munich, and they will because of our overseas immersion program or introduction to the German chemical industry, where they will head to Germany. And so if they are interested and there's an opportunity for them to pursue their integrated work study program in Germany, they can. And with the networking that they do later on, they can apply for a job in Germany as well. So this is the powerful part of our program. For the exact topics that we will go through in the study program, this is it. So for data engineering, they will go through Internet of Things, industrial software engineering, data processing and analytics, as well as industrial automation. Plus, there is also some practical components so that it is not just theoretical, okay? For additive manufacturing as well, basics in polymer engineering, polymer and polymer tech, materials and failure analysis, as well as 3D printing. And then, of course, the practical component, because for science and engineering, the practical component is a must for them to be more hands-on and be work-ready, as we mentioned. So what does all this add to our chemical engineering graduate? So remember, you are going through a chemical engineering degree. That means that you will be certified as a chemical engineer. And that means that with additional skills in Industry 4.0, that will put you at an advantage over a traditional chemical engineer who has not gone through our specialization training. With that in mind, what can they do after they graduate, which is what all of us are interested in. For a chemical engineering graduate, it is very vast and wide. There's a lot of things for the chemical engineering graduate now. Because why? Because it is very interdisciplinary. Chemical engineer with our training can go to environmental industry, can go to food, can go to fragrance. There's so many things that a chemical engineering graduate can do in these industries. And it's not limited to just these industries. There's also other industries, and within each industry, there's a lot of job opportunities for our chemical engineering graduate as well. So this is a very powerful program. If they can be all of this above, and then it's really not limited to all of this. Okay? Currently, our integrated work study program partners, you can see the list of companies here. There are a lot of big names there. There are also SMEs, okay, startups. So these are the companies that our students went in. We are very proud of it. And we are also the academic supervisors for some of our students. How does the curriculum structure look like? This is what you have to go through, right? In year one, you will go through your fundamental science training, right? Your math, your chem, bio, physics. And then, of course, being an engineering topic, it's quite physics dependent and math dependent. And after that, after you finish your fundamental science training, you'll go to the core of a chemical engineer, heat transfer, of course, plant design as a major topic if you have gone through chemical engineering diploma training. And there are many topics that builds a chemical engineer, and you can find all of them in the curriculum. And then later on, you head to your specialization where you can choose either data engineering or you can choose additive manufacturing. So after you complete your specializations, after you complete all of your modules, you will go for a 3-week trip in Germany. And I believe it's compulsory in SIT to go for this 3-week trip. And after that, you will complete all of your modules required to head for your final training, which is the integrated work study program, and complete a bachelor thesis on top of that. Okay? So, of course, this makes a chemical engineer with the specialization training. But at the same time, you also need to go through soft skills training, like design innovation, communication skills, that is university-wide. I promised a bit more about the overseas immersion program. Apart from the TUM campus in Munich, okay, chemical engineering is actually located in a further campus, but it's the largest campus of TUM as well. So apart from the campus itself, what will we be doing? We will be going to cultural visits. We'll also be doing industry visits. And I believe that this is what attracts our students as well when they head to, for example, Tufsuit, right, as a company that really does a lot of topics, but chemical engineering is one of their strong suits. So for these 3 weeks, they will go to different research institutes, different industries, different cultural visits. And I believe that this will be very beneficial for our students' global perspective, global outlook. They'll get exposed to not just the Singapore's chemical industry, but the German chemical industry as well. The Integrated Work Study Program is a 12-month program. What does it aim to do? Right? It aims to provide our students with professional skills that they need to be work-ready. And then later on, with whatever they learn, they put it into practice, hands-on. And then after that, after they mastered the professional skills required, integrated into practice, then comes the innovation part that we are very interested in. Because you must be good at what you do before you set out to do new things, right? So that is something that we are very interested to do. And it will be a 12-month training. They will be attached to a company full-time. And then later on, with the industry experts, teaching them the necessary work-ready skills, we also teach them the communication skills required for a scientist, for an engineer, right? And then later on, they will be ready for work once they graduate, and hopefully be able to get work immediately when they graduate. Okay? This IWSP can be done with local companies as well as overseas companies. And we have to say that. So if you have a company in mind that you really, really, really want to go, but it's not in Singapore, and if you get the chance to, you get the placement that you require, I think SIT can work on getting you to be attached to that company in an overseas setting. And of course, TUM's linkages come in, right? Where TUM's partners in the industry is very strong. That means that there is actually an existing network that we can tap on, okay, for our students.